wavelength. So here, this is the definition of guide wavelength. The distance traveled by the wave in order to undergo the phase shift is 2 pi radians. So here that means whenever the distance, whenever wave propagates in the waveguide, then the distance traveled by the wave. So whenever the distance traveled by the wave is 2 pi radians, reaches to 2 pi radians, then that distance is called as guide wavelength. So here, to explain, to understand clearly definition of guide wavelength, now we will see with a simple diagram of rectangular waveguide and how we can derive the guide wavelength. So it is very easy to understand by seeing the simple diagram, so that is related to guide wavelength. Now we will see that diagram. Here, this is the simple diagram that we understand clearly the definition of guide wavelength and what is guide wavelength. So this is the rectangular waveguide. Here A is the length of the breadth of the rectangular waveguide, and B is the width of the rectangular waveguide, and this is the wave propagation direction in rectangular waveguide. So here see that here this is called as lambda g. That means the distance traveled by the wave in order to undergo the phase shift is 2 pi radians. So this is the distance. So 2 pi radians means here up to this half cycle, positive half cycle, the phase shift is pi, and this one 2 pi. So here the distance traveled by the wave in order to undergo the phase shift is 2 pi radians. So the corresponding to this distance is called as guide wavelength. So this is about guide wavelength. So now we will see, and now we have there is a one relation between guide wavelength and phase constant. So the relation between guide wavelength and phase constant is lambda g is equal to 2 pi by beta. Here this is the relationship between guide wavelength and phase constant. Here the guide wavelength and phase constant are inversely proportional to each other. Here this is a simple relation between guide wavelength and phase constant, where lambda g is nothing but a guide wavelength and beta is nothing but a phase constant. So this is the relationship between guide wavelength and phase constant. Now we have another relation between guide wavelength and free space wavelength and cutoff wavelength. So now we will see the relationship among guide wavelength and free space wavelength and cutoff wavelength. So here the relationship among guide wavelength lambda g and free space wavelength lambda naught and cutoff wavelength lambda c is that 1 by lambda square g is equal to 1 by lambda naught square is equal to 1 by lambda square c. So this is the relationship among guide wavelength and free space wavelength and cutoff wavelength. Here one important point is that the guide wavelength is different from free space wavelength. So these are different wavelengths, not equal lengths. Here guide wavelength is different compared to free space wavelength, and free space wavelength is different from cutoff wavelength. So this is the relationship among these three. Now we will see phase velocity. Now we will see the phase velocity. Phase velocity is represented with letter Vp. So this is a representation of phase velocity. So the definition of phase velocity is phase velocity is defined as the rate at which the phase changes in terms of guide wavelength. So this is the definition of phase velocity. Phase velocity is defined as the rate at which changes its phase, at which the wave changes its phase in terms of guide wavelength. So this is called as phase velocity. Phase velocity is nothing but the phase velocity is defined as the rate at which the wave changes in its phase in terms of guide wavelength. So the wave changes its phase in terms of guide wavelength, that rate is called as phase velocity. So the definition of from that definition, we in terms of equation how we can written, we will see. First of all, the phase velocity it is represented with Vp. So Vp is equal to lambda g by unit time. So Vp is equal to lambda g by unit time. Here Vp is equal to phase velocity, lambda is equal to guide wavelength and unit time. So according to the definition, the rate at which the wave changes in its phase in terms of guide wavelength. So this is the equation for the definition. So now we will simplify this one. Here lambda z is equal to Vp is equal to lambda g into f. F is nothing but a frequency. Here frequency, we have one relation among frequency and time. F is equal to 1 by t. So according to that, here unit time is nothing but a 1 by t. So in the place of unit time, we can written a lambda g into f. So the and next is equal to lambda g into, now we will write that lambda g into 2 pi f by f. Here we will write as 2 f into f as 2 pi f by f. Here when if 2 pi, here this is the same. So whenever 2 pi cancels, f is there. So that's why here we simply modified that. We simply add and divide in 2 pi and 2 pi. So here 2 pi f by 2 pi is nothing but a f. So here Vp is equal to lambda g into 2 pi f by 2 pi. Now we will write this one as 2 pi f by 2 pi lambda g. So we can also simplify this one as 2 pi f by 2 pi. So this one brings to up here. Then if this one is comes there, then it has lambda g. So consider this one as 2 pi f by 2 pi by lambda g. Here next it is modified as 2 pi f by beta. And we have another relation among lambda g and guide wavelength. We also derived in the in previous that lambda g is equal to 2 pi by beta. So before this only we derived the expression for guide wavelength. Guide wavelength is equal to 2 pi by beta. According to this, if we have here 2 pi by lambda g, now this one can written as beta is equal to 2 pi by lambda g. So according to this, we can substitute in the place of 2 pi by lambda g, we can substitute beta. So 2 pi f by beta. And now here 2 pi f we can written as omega. So we know that omega is equal to 2 pi f. So Vp is equal to finally omega by beta. So this is the simple equation for phase velocity. Vp is equal to omega by beta. Here omega is nothing but a frequency. Here 2 pi f. Omega is equal to 2 pi f and beta is a phase constant. So this is the phase velocity definition and equation. And we have another expression for phase velocity also. Now we also see that expression also. The another one is group velocity. Group velocity is represented with the letter Vg. And now the definition of group velocity is defined as the rate at which the wave propagates through the waveguide. So this is called group velocity. Group velocity is nothing but it is the rate at which the wave propagates through the waveguide. So this is the simple definition of group velocity. Now the equation, if we can written this as in the equation form, then the equation is Vg is equal to d omega by d beta. So the rate at which the wave propagates through the waveguide. So this is the formula for group velocity Vc. And we can also written group velocity in terms of cutoff frequencies and cutoff wavelength, and phase velocity also we can written in the cutoff wavelength and cutoff frequencies. So in next lecture we will see what is cutoff frequency and what is cutoff wavelength, and how we can written phase velocity and group velocity in terms of cutoff frequencies and cutoff wavelengths. So if you like this lecture, you can subscribe my channel and you can click bell icon to get more notifications and more